Okay, so our next video is going to be on Newton's second law of motion. And Newton's second law of motion has to do with force, acceleration, and mass. So acceleration is an unbalanced force causes something to accelerate, right? So acceleration is directly related to the size of the force and the direction of the force. It accelerates in the direction that you push or pull it, an object. So in other words, the larger the force, the larger the acceleration. So the larger the amount of effort I put into pushing something, the faster it's going to go, is what that's saying. So also, the smaller the force, the smaller the acceleration. So if I push it just a little bit, it's not going to go very fast. But there is a twist in this. So acceleration is inversely related to the mass of the object. And that kind of makes sense, right? So using the same amount of force, a large object is going to have a small acceleration, and a small object would have a large acceleration. And that kind of makes sense because we talked about it earlier that, you know, a heavy object is harder to push than a smaller object. So Newton, you know, he was a genius, right? He observed these rules of acceleration and came up with the second law of motion. It has a formula and a law. So here's Newton's second law. The acceleration of an object is directly proportional to the net force and inversely proportional to its mass. Or in other words, force equals mass times acceleration, or F equals ma. Okay then, so to do these problems, you're going to need to know the units of force, mass, and acceleration. So the units for force are newtons, capital N. The units for mass are always going to be kilograms in this equation. Now we know we can measure it in grams or pounds and whatever, but in this equation they have to always be kilograms. And in this equation the acceleration units always have to be meters per second squared. Okay, so let's try a problem. So it says, the engineers at Johnson Space Center must determine the net force needed for a rocket to achieve an acceleration of 70 meters per second squared. If the mass of the rocket is 4,500 kilograms, how much net force must the rocket develop? So let's find the given information. So right here, they show us the acceleration. And here they show us the mass. So the acceleration is 70 meters per second squared. And the mass is 4,500 kilograms. And they're asking us right here for force. So that would be what our unknown is. Our equation is force equals mass times acceleration, and that's always going to be on your pink sheet. And to plug in, you're going to have acceleration times mass. Okay. So 70 times 4,500. So 3,150,000. And so our units are going to be kilograms times meters per second squared because it's mass times acceleration. Okay?